The next example is another two-triangle scenario that will replay very much like the first. So if you feel like you understood what happened in that first example, you could probably bypass this one, or at least maybe skip ahead and check to see how your answer turns out if you run through it on your own. But we'll go ahead and draw the triangle using the given information like we had done previously. So we've got angle A is going to be this 25-degree angle over here on the left. B is going to be our angle over here on the right. C up at the top. That means length A across from angle A is this 15 right here. Length B across from angle B is 25. Length C is down here on the bottom. So if we set up our law of sines, we've got sine of 25 over 15 equals sine of angle B over 25. So if we cross multiply and then isolate the sine of B, we're eventually going to get sine of B equals 25 times the sine of 25 all over 15. And so if we calculate that out on the right hand side, take the inverse sine of both sides, we're eventually going to get angle B as having a measure of 44.8 degrees. So that's enough now for us to figure out what angle C is. So if we add 44.8 to the 25-degree angle A that we have, that gives us 69.8. If we then subtract that from 180, we get angle C in this first scenario is 110.2 degrees. So that looks like a reasonable measure for that angle up there. And so now we just use the law of sines one last time to figure out what the length of side C is. So we can go back to that same sine of 25 over 15 as the start equals the sine of 110.2 over length C on the other side. And so then again, cross multiplying and then dividing by sine of 25 on both sides gives us length C as being 33.3. And so that's consistent with what we would expect by the size of the angles. Angle A is the smallest angle, has the smallest side. Angle C is the biggest angle, has the biggest side. So now we need to figure out what the second scenario gives us. So I've got to take this side B and I have to swing it to here. So maybe we'll change colors so that we know what we're working with here. So again, if this angle is 44.8, that means this angle is 44.8. So to figure out what this new version of angle B is, it's going to be 180 minus that 44.8. Because if we've got a straight angle with those two together, they're supplementary angles. We can take 180 minus that 44.8 to figure out what the new version of angle B is. And so then we get angle B is equal to 135.2. So that coupled with angle A still being 25 degrees, add those together and subtract from 180. That means that angle C turns out to be 19.8 degrees. And so now we only have one thing left that we have to find. We have to find this new shorter length C. And so that's where the law of sines comes in. Sine of 25 over 15 equals the sine of 19.8 over length C. So a little cross multiplying, a little dividing, yields C is, if we round to the nearest tenth, 12.0. So here's the second version of the triangle that's possible, the one where angle B is obtuse. And then over here is our result for the original configuration that we drew, the one that was in all black, with angle B being acute and angle C up at the top being obtuse.